Now that I said take 2, they're going to know that I did it twice. Oh no. Okay, multiplies to be 6, adds to be -7. How about, let's do this right. How about -6 and -1? How about -6 and -1? Which I said the first time. Yeah, let's go with that. Multiplies to be absolutely, adds to be absolutely. So I go 3x squared minus 6x minus x plus 2. Say, I knew that.
I knew that.
All right. 3x goes into both, leaving x minus 2. If it's a negative, we pull out a negative un. Negative divided by negative, positive by negative. Cool. It factors into 3x minus 1, x minus 2. From yesterday's sheet, was one of the very first directions factor it? Was that one of the very first directions yesterday? So yep, it was. All right. So I'm now going to write the factored form up here. So I'm writing, and I think you are too, actually. F of x, x minus 1. And now I'm looking at the problem at the bottom is x plus 4. All right. It says holes in the graph. Have you yet been taught what a hole in the graph is? No, there's no holes on this one. I'll teach you once we get to one. None. There are no holes in the graph. The order I had that is zeros. All right. I'm going to teach it at 2 different levels. You decide what level you want to be with. If you want to understand why this is the zeros, look at this real quick. Hey, and if you don't understand why you just want to do it, don't pay attention for 12 seconds. What is 0 over 6? 0. What's 0 over 13? It's a 12. What's 0 over x? 0. When the numerator is 0, it makes it a 0. And your directions from yesterday, which you have out, say this, zeros, where the numerator equals 0. So what we have to do now is the following. We have to write 3x minus 1 equals 0. It's like we're doing the big T. X equals 1/3. We write x minus 2 equals 0, like it's the big T. X equals 2. And now we write them as 1/3, comma 0, 2, comma 0. Those are the 0. That's the work. And those are the zeros. The next thing on today's sheet says horizontal asymptotes. Horizontal asymptotes. I believe it is spelled A-S-Y-M-P-T-O-T-E, asymptote. It is where something is close, 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 but never gets to. And now I am reading off of yesterday's directions. And yesterday's direction says, if the power of the exponent, the degree of the top is bigger than the bottom. What is the degree of the, let's look at the original problem. The original problem, the degree is what? It's, on top is 2, the bottom is 1. The directions say, if the power of the top is bigger than the bottom top, there's no asymptote. Is the degree of the top bigger than the bottom? Horizontal asymptote? Right, none. I'm going to try to explain why on that a little bit later. Vertical asymptote, these are up and down. Kevin was here on February 28th. He was not here yesterday. I read that you weren't here yesterday. Okay, the vertical asymptote. For those that want to understand why, use the word that starts with U that you taught when zero's on the bottom. Undefined. And undefined showed you an up and down line. Undefined showed you an up and down line. That's why. The vertical asymptote. Directions from yesterday. Directions from yesterday say where denominator equals 0. Please set x plus 4 equal to 0. X equals -4, and we leave that like that. All right. For the people at home, we're going to go for a ride. I bet the people at home think this is fun. All right. The zeros, would you please, how about we put maybe 5 or so dash marks going up, down, back, forth. We need to do more, we can do more. The 0 happens at 1/3, so about here, and at 2, about here. Nice big dots, even though in reality they take up no space. We're not going to go there today. All right. The back and forth, there are no horizontal asymptotes. There are none. The vertical is at x equals -4. 1, 2, 3, 4. All of this is available without a graphing calculator. All of this is available without a graphing calculator. Now we are going to use the graphing calculator to finish it up. So I'm typing the original problem in. You can too, if you want. Parentheses on the top, parentheses on the bottom. I typed in parentheses on the top, parentheses on the bottom. Maybe you are typing the original in too. And when you enter, you're going to go, whoa! Or maybe zoom 6. And then you're going to go, whoa. Now that's pretty neat. It's like, did anyone's graph see anything else? Mine doesn't. Wish it did. Done? Mine, I wish it did. Let's see if I can see anything else. Well, I think that's about it. It's actually weird. Apparently that's our graph. Cool. Hi.